Imaginary derivatives for IIT JEE. You might be surprised to know the fact that there are imaginary derivatives. In fact, this comes from the idea that we are used to with finding d to the power n by dx to the power n for some integers n. There have been times where people just want to extend the domain of n to any real numbers or any complex numbers, and with that pursuit, this idea came into existence. So let me try to show how do we calculate such imaginary derivatives. First of all, let us deal with the derivative of x to the power n. This is n times x to the power n minus 1. If we deal with second derivative of x to the power n, we have to differentiate this again and we get n minus 1 by x to the power n minus 2. This can be written as n by n minus 2 factorial times x to the power n minus 2. You can similarly write this as n factorial. N factorial by n minus 1 factorial x to the power n minus 1. If you find third derivative, it's in similar fashion. We get the similar result, that is n minus 1 n minus 2 by x to the power n minus 3, and that is n factorial by n minus 3 factorial x to the power n minus 3. Now here comes generalization. Now we can generalize that for any power t, d to the power t, for any power t, we can write this as n factorial by n minus t factorial, and then x to the power n minus t. Yeah, we can just check this generalization from the previous derivatives, and the way we generalize this, it should be typically tb should be a positive integer, but we just try to extend and see what result we get, and that way we have extended t to any complex number. Now let's say we can substitute I for t, and then also n as y. Now we substitute both n and t as I, and we get d to the power I of dx to the power I of x to the power I. This is equals to n factorial, that is I factorial by I minus I factorial x to the power I minus I. When you say this is I factorial by z factorial is 1, x to the power z is 1, yeah, and the result is I factorial. So it's kind of misuse of the generalization that we made, cause the domain of t could not be a complex number. But yeah, sometimes misuse makes sense, because there have been times when we generalized different ideas and those were actually true and they had actual meanings. Like, so for example, the factorial is for integers, and we can now calculate half factorial to be root pi, and it has some meaning when we said this with the gamma functions. So there have been times those have meanings. And another example is also that the binomial expansion of 1 plus x to the power n. Originally, n was to be a positive integer, but later on, Newton extended to negative integers, and that did work, and that made sense in some way. So yeah, so this is just kind of misuse, but it can make sense if you find the possible interpretation for this thing. And yeah, I hope you enjoyed this problem and look forward to seeing you in the other problems too. Thank you.